In this video, we're going to review what polynomials are and some of the things you can do with them. So a quick rundown of the terminology here. A monomial is when you have a number and then variables raised to whole number powers. So 5x squared, 17x cubed, things like that. Those are monomials. Binomials are when you take two monomials and you either add or subtract them together. Then you have two terms, that's called a binomial. If you have three terms, that's called a trinomial. And then the generic word that covers all of these is called polynomial. Now, polynomial, you could have 17 terms, or you could only have one term. They're all still called polynomials. And the generic way we can write it down is some number times x to the highest power, and then another number, x to the power smaller than that, and on down to just x to the first power, and then possibly a last number with no x there. We have the first term, the highest power, is called the leading term. The coefficient of that first term is called the leading coefficient. The last number is called the constant term, and the highest exponent you have is called the degree. Now, when we have polynomials, we can add, subtract, multiply, or divide them. If you're going to add them, all you need to do is look for like terms. So 2x squared, another x squared, makes it 3x squared. Minus x plus 3x is plus 2x. And plus 1 minus 1 is 0, which means we don't even really write that down. That's the result of adding those. When you are subtracting, the only extra step you have to worry about is distributing that negative sign in. And after you've done that, you once again look for like terms. X squared minus 2x squared is a negative x squared. There's only one term plus x. And then minus 2 plus 2 is also 0. So the answer here is negative x squared plus x. Then we have multiplication examples here. So for multiplication examples, I have a monomial times a binomial. To do that, we just use distributive property. 3x times 4x is 12x squared. 3x times minus 5 is minus 15x. And there we go. Part D here has a binomial times a binomial. And when you're going to multiply those out, the easiest way to do that is something called FOIL. Now, you don't have to memorize this if you don't want to, but basically you need to think about when you're multiplying these two binomials, you need to multiply everything in the first one times everything in the second one. Some people that don't like FOIL, they will do something like a box here. So they would say things like x plus 2 and 3x minus 1. And they would do every possible multiplication together. It doesn't really matter how you want to organize things as long as you multiply them all together and get the right answer here. I personally like FOIL. So I'd have 3x times x is 3x squared for your first term. The outer, I'd have x times negative 1 is negative x. The inner, I'd have 2 times 3x, which is 6x. And the last would be 2 times negative 1, which is minus 2. And this then combines to make 3x squared plus 5x minus 2. Now there are a couple of special cases here. If you ever have x minus a number times x plus the same number, you are certainly fine to just FOIL it out and get the answer yourself. But it can be useful to know what happens, that it's always going to work out to be x squared minus the number squared. As an example, if you had x minus 3 times x plus 3, without doing any middle work, I know it's going to work out to be x squared minus 9, so it can allow you to save some time. Also, when you have a binomial that is being squared, don't forget that really means that you write it out twice and FOIL it out, and it's always going to give you x squared plus double the number x plus the number squared. Again, it's in the shortcut. It's not required to know, but it can be useful sometimes. And the last thing we can do with polynomials is we can divide them. Unfortunately, dividing polynomials is a pretty big pain. Even more unfortunate, there are times where we still have to do them. So let's kind of go over how we can do our long division here. So you always write the thing you're dividing by on the outside of the division bar. And then you go ahead and write the other part inside the division bar. And then here's how I teach this here. So I say, okay, first things first, you look at the outer number, you look at the first thing in there, x to x cubed. Think about what do you have to multiply x by to get x cubed. I had to multiply by x squared. That's what I call the goes into stage. Next one is going to be the multiply stage. So I take that x squared and multiply by everything in the front. X squared times x is x cubed. X squared times minus 2 is a minus 2x squared. Stage 3 is going to be subtract. And before I do that, stage 4 is going to be bring down. Those are our 4 stages here. So when I subtract, I'm subtracting the entire polynomial, which is just like up here. And I have to distribute the negative sign in. So I'm going to distribute the negative on the bottom there. And let me get a new color here. So I'd have x cubed minus x cubed. I get 0. If you don't get a 0 in that first part, you did something wrong. And then I would have a negative 3x squared plus 2x squared is a negative x squared. And then I do the bring down part. Then I'm going to repeat here. So it goes into x, goes into negative x squared, negative x times. Then I do multiply. Negative x times x is negative x squared. Negative x times negative 2 is plus 2x. Then I do my subtraction where I distribute in the negative sign. Let's get another color here. Let's choose this one. Negative x squared plus x squared is 0. 5x minus 2x is 3x. Bring down the plus 2. Then I'd say x into 3x goes 3 times. Multiply. 3 times x is 3x. 3 times minus 2 is minus 6. Do my subtraction. And 2 plus 6 is 8. And at some point in time, you're going to get to something down here that has less x's than you started with. So in the original thing I had 1x and I have no x left. I have smaller x's there. Once you know that, that's going to be your remainder. And so to answer the problem here, my quotient, that's going to be x squared minus x plus 3. And my remainder is 8. And sometimes we would like to write the answer as follows: x squared minus x plus 3 plus a remainder 8 over x minus 2. And just a little side note in case you're wondering why we do it like that, let me kind of go over here in the little corner. If I had 5/3 and I wanted to rewrite that, I would say 3 goes into 5 one time with a 2 remainder. And we can write that as 1 and 2 remainder over 3. So we have the quotient and the remainder over the original number, quotient, remainder over the original number. So that's where that kind of notation comes from there. But regardless, it just depends on the problem, which way they prefer you writing it. If I were to give you instructions like this, I wouldn't care. But there are some problems in your future math career where they really need it written a specific way, because you're then going to go on and use this for later parts of the problem. So it's good to kind of get used to all the different ways you could write your answer here.